Okay, students, welcome to week 2. This is the PowerPoint that I have posted, except this one will have narration to take you through it. And I'll also be able to explain your assignment for the week as well. I'd hoped to have a webcam embedded in this as I went through. I was not able to get that set up. I apologize for that. I should have it ready to go next week. So, we're going to be talking about the importance of science in a very deceptive world, and methods for us to decide what is true and what is not, and how do we get there. The scientific claims we hear, whether it be global warming or anything like that, how do we know it's true? How do we know, if someone just comes out of the woodwork and says, vaccines cause autism, how can we prove that wrong? Because it is factually not true. So, this is Carl Sagan. He was a very famous scientist. The original Cosmos series, this gentleman did that. And he has a eerily relevant quote where he says, "We live in a society exquisitely dependent on science and technology, in which hardly anyone knows anything about science and technology." And he's kind of hit the nail on the head. We've become so reliant on technology and science for our everyday lives, be it smartphones, lane assists in cars, rear view, backup cameras, medical technology, but we don't understand how it works, and that's a recipe for disaster. Similarly, I think we can add in history to this. We are sort of living in an era without much contextual history, and we're doomed to repeat it. But that's another topic for another day. So that's Mr. Sagan with this great quote. So, now the internet and its expansion into social media has given everybody a voice. And everybody does deserve a voice. But when you have people claiming to be experts, or when you have people spreading misinformation, then it gets to be a problem. So everybody does deserve to have a voice. Misplaced confidence in false information can make anybody's voice very dangerous and can make the truth a very hard thing to find. So inaccurate and manipulated science can be incredibly dangerous and deadly, as we have seen in the past. And so we want to sort of figure out what methods do we have to really figure out the truth. So we hear stuff every day. The earth is flat. There are chemtrails coming behind commercial jets. The moon landing was fake. Climate change isn't real. And it's hard to know what is true and what is not. I can tell you, all the above, just like the wolf says here, or the coyote, none of that is real. So with so many voices out there claiming to be educated or claiming to be experts or an authority, finding out what is true and what is not can be very stressful and difficult. But we have to be very, very careful about the places where we get our information, especially when it comes to science, because it is a very narrow field. When you get into something like, let's take the topic of the day, to epidemiology that deals with epidemics, that is such a small field with so few experts. You have to really make sure that you're finding the correct information. Because even a medical doctor, like a general practitioner that you may go and see, they do not have the level of education and experience that an epidemiologist has. And so just because someone has, some letters behind their name, be it PhD, MD, DDS, it does not mean that they're an expert. You have to look at where their field of study is. So sadly, we see more and more how science can be manipulated, misrepresented, misinterpreted, or just even flat out lied about. Just because you put on a lab coat and you stand in front of a government building does not mean that you've performed the tasks to prove your claims. And so you, yourself, you're the key to finding out what is true and what is not. I am the key to finding out what is true and what is not, and we all have that power within us. So how can we do this? So here's some sticky notes on how we can do it. First off, consider the source. Where is the information coming from? Is it a personal blog? Does this person have, sources to back it up, experiments to back it up? Is it an editable information site like Wikipedia? I mean, you can get some good information from Wikipedia for sure, but anybody can edit Wikipedia, which means I can go in knowing nothing about, Canadian Prime Minister Justin Trudeau, and I can alter his biography. That's not a trusted source. Is this a scientific group? Is this something that's been in or established for years and years and years? So we can look for confirmation. And that means, are there other outlets that are reporting the same thing? Have they done similar experiments and come to the same conclusion? A dangerous thing we cannot do is look for affirmation. Affirmation means you're looking to affirm your beliefs. And it's really easy. If you fully believed that the trails behind planes were chemtrails, and you want to go study this, you're probably going to look at sites that back up your feelings, your opinions, but you really have to look at ones that maybe counter it. So that way you can get both sides of the story and figure out which side makes most sense with where the information is coming from. Another big area that we have to look at is, sorry, let me hop back. This isn't good. I'm going backwards. Let me exit out of this real quick. Hop back to our original slide. There we go. Let's go back in from there. I apologize for that. So back to our sticky notes. So who is funding it? That's a big thing too, because you can hear all this stuff like, oh, milk is super healthy, milk does this, milk does that. And then when you look at who pays for those ads, it's the dairy farmers. Are they wrong? Maybe not. But they're a little biased in what they're going to say because they want to keep their production going. So you can also talk to others, talk to friends, talk to experts in the field, talk to educators, and try to build up a little robust group of information. Think about if the claim is logical or not. Does it even make sense? Is this something that can be testable, that can be repeatable? Or is it, if someone claims like, there are aliens out there and I know this because one came to me at night and told me about their whole civilization. That could be true, but it is not testable, it is not repeatable, and so it's hard to take just something at its word if there's not something to back it up. And so you try to look at things from the opposite point of view. Sometimes you have to be a skeptic. You want to be a skeptic until you gather enough information to convince yourself this is true. So now, let's talk about opinion versus theory, or it could even be opinion versus fact, because those are two competing ideas there. So opinion is just a view or judgment formed about something not necessarily based on fact or knowledge. You see my example down there. I say dolphins are the worst animal on the planet. There's no knowledge behind that. There's no fact behind that. There's no stats to back me up. I just think they're arrogant creatures. That's my opinion. You may love them. All the more power to you. And then there's scientific theory or scientific law, scientific fact. It goes by a bunch of different names. But this is a coherent group of propositions formulated to explain a group of facts or phenomena in the natural world and repeatedly confirmed through experiment or observation. So it's not just a claim. It's not just this happened so it must be true. But this is repeated experiments, repeated observation, to where after enough time and enough tests, you could say this is more than likely true. And so you have that example down there of laws of planetary motion, which we will cover later on. It'll be fun. Not today, though. So that's where we get into the scientific method. And we're not going to go through each and every step and talk about each one is, because you do the scientific method every single day in your normal thinking. So all the scientific method is just a roadmap for good thinking. It's an experiment in truth. It's a way to determine truth in a objective way, not a subjective or biased way, but in an unbiased and very objective way. And the beautiful thing about science is we can always change our opinion if new facts are presented. If we learn new things, if we develop a new technology that proves something wrong, we can change our minds. And it's great. That's one of the best things about science. You're not stuck into a little opinion. You can change it based off of new evidence. And so we kind of live in a dangerous time where anyone can spout anything and claim to be an expert. And people will take it as true because they don't want to do the research themselves. And this is where we get the war on science. Because it can be manipulated, you can manipulate data, you can skew things to be the way you want them to. And we're going to see how that works. So now, you had this on your discussion, so I'm not going to play it again and you can watch it, but man, do I love this. My favorite part is when he says, you can't choose to believe or choose to not believe that E equals MC squared, you don't have that option because it's true. These are empirical truths that we have found out. And so make sure you watch that because it's awesome. So ultimately, here's our whole circle and cycle of the scientific method and how it goes. You start with an observation that develops into a question. You can form that hypothesis or educated guess, perform an experiment, collect the data, analyze it, and come to a conclusion. You do this all the time without even thinking about it. It's just good thinking. So let's look at an example. Go away, top part. Okay. So step 1, forming a question through observations. So I love candy. It's one of my favorite things in the world. And I've always worried, what if I come across one of these vans that says free candy on the side? Will I go in and get free candy? Or am I being duped into being kidnapped and somebody harvesting my organs or something? So I have to form a question through my observations. I want the candy, but I'm worried about being murdered. I can ask myself the question, will I get candy from this van or will something bad happen? That's my first step. It's all of our first steps in thinking. Forming a hypothesis. So I can form a hypothesis by saying, I think if I go in there, I'm going to get free candy. Or, I think if I go in there, something bad's going to happen. So, once I have my hypothesis, I form my experiment. For my experiment, I'm just going to sit back and let people go to that van to get free candy and see what happens to them. So I sit there and I watch and people go in, and I'm testing my hypothesis, and I see some people come out, with candy and they're happy, or maybe I see people not coming out and the van takes off or something. But everything that I see, I record down as my data. And once I have all this data, I'm able to go back and reflect on it. When I can reflect on it, I can analyze it, look for trends, look for connections, and that's very, very important. Check this out. This is funny. Oops, I did it again. So let me go up. I got a hop back slide, but it's something I just noticed. So I wanted to show you because I make mistakes a lot. But I go from step 3, step 5, conclusion. I skipped a step there. But so if through my observations and after my analysis, I see a lot of people coming out with candy and they're very happy, my conclusion can be, if I go to this van, I'm going to get candy and I'm going to be happy. And that's all the scientific method involves. That's just good thinking, the experiments in truth. That's what Dr. Tyson was talking about. So let's see how this can apply in the real world, because it is very important for us to think critically at all times. Sometimes when we get data, and it could be correct and factual data, it could be presented in a manner that can be deceptive and misleading. So this usually happens when someone wants to relate correlating data, so data that matches up with causation. So correlation just means a relationship or a connection between two things. And then the causation is the act of causing something. So me sticking a fork into a light socket would cause me to get electrocuted. That act of me sticking the fork in, that's the causation. It's causing me to be electrocuted. So it is vitally important for us to know that correlation does not always equal causation. Sometimes it's just a matter of, I'll say, luck or happenstance or coincidence that certain data points line up. And we're going to look at some examples because this is what your assignment is based off of. So if we look at this chart, if you just look at the lines right now, you can see they more or less match up. They rise when the other rises, and they dip when the other dips. But let's look at what the data is. So this is the number of people who have drowned by falling into a pool, along with films Nicolas Cage appeared in. And it's pretty weird. Like if you go through from 1999 to 2009, when Nicolas Cage appears in a bunch of movies, seems like a bunch of people drowned by falling into pools. 2003, when he didn't star in a bunch of movies, well, not that many people drowned by falling into pools. So it correlates. That data correlates. It matches up. But does one cause the other? No. Is Nicolas Cage the best actor in the world? No. But his acting does not cause people to drown by falling into a pool. That is a perfect example of correlation not equaling causation. Let's look at another example that might be a little bit harder to separate. Oop, did it again. So, this is another one. Let's look at the graph here. So this graph shows ice cream sales and shark attacks from January to November. So we can see that they both spike at the same time and they both go down at the same time. But it really doesn't make sense to think that just because ice cream sales are higher, shark attacks are going to be higher. Or just because shark attacks are higher, ice cream attacks are higher. Ice cream attacks. Ice cream sales are higher. I apologize for that. But the reason that this data correlates, if we think about it, is because as the temperature gets hotter, more people want a nice refreshing treat like ice cream, or more people go outside and go to the beach and hop into the water. But once you hop into the water, you're in the shark's territory and your chances of getting attacked greatly increase. So that's why this data correlates. So it matches up, but it is not the cause of one another. Okay, so that's where correlation does not equal causation. But sometimes it might. Sometimes the data correlates. Look at that, 2 commas in there. What am I thinking? So sometimes the data correlates with causation, and we can connect the dots. If we look at the data with a critical eye, we can make mental connections and then see why one may relate to the other. Let's take a peek at that. So now this is a graph of going between 1860 and 2020, which we are in. And we're looking at sea level rise in millimeters as opposed to average global temperature. So you can see that sea level rise. Now they didn't use the best colors because they look very similar. But if you follow the sea level rise line, it's trending up and to the right. If you follow the global temperature anomaly, which is like how much it's off of its normal, it is also going up to the right. So this is a case where the data is correlating, but we have to think, does this really mean causation? Well, if the temperature gets hotter, then more ice will melt, and also water expands when it gets hotter. And so if you had this expansion of water and more water being added, it makes sense that the sea level would rise. This would be an example of where the correlation does lead into causation, or at least possibly can. And so this is going to be an important part of your assignment, which I'm going to get to. So lastly, we're going to wrap it up with this slide that we all need to be critical and objective in determining the truth or validity of a claim or idea. If we blindly accept everything to be true, we can easily be fooled. Just like I don't know much about cars, so when I take my car to the mechanic, I'm trusting that they're going to be honest. Because if they come back to me and they say a bunch of technical terms that I don't know, I can easily be duped. Now, I can fix this by learning about cars so I don't get taken advantage of, but sometimes that can be hard. But so we need to examine everything with a close eye and ask, does this make sense? And so you want to use this sort of scientific thinking in everything you do. And typically we do. Now, so I have this little insignia here, this little crest, if you will, with the saying Nullius in Verba. And Nullius in Verba is the motto of the Royal Society of England, and of which Sir Isaac Newton was the president at one time. He is my personal hero, along with other scientists. But Nullius in Verba translates to on the word of no one, which, if we want to roughly translate that, it would be take nobody's word. So do the work for yourself. Find out for yourself. Think critically. The answers may not always come really quick, but if you think critically, logical answers will appear. So now in your assignment, what you're going to be looking at is a bunch of different graphs, and you're going to have to study them closely and figure out, does this data correlate? And then explain why or why not. So there we go. There's week 2's lecture. There's week 2's PowerPoint. I will have this up for the whole semester, so you'll be able to come back to it and watch it if you want. And thank you for joining me, and I'll talk to you later.